Hello and welcome to my channel Networking with H. In this video of CCNA series, we'll learn about router functionality, types of router, advantages of using router in the network. At the most basic level, a router connects two or more networks together. Or for two or more LANs to be interconnected, you need a router. It is a layer 3 device because it operates at the layer 3 of the OSI model of communication. It uses IP addresses to route the packets and is responsible for the path determination. In addition to the connecting multiple networks together, the router also allows network devices to communicate and multiple users to access the internet. As the name implies, it routes traffic between the devices and the internet, or between devices on the other LAN. Let's see how the router works. To understand how the router works, let's start with an example of how post office system works. If a person wants to send a postcard to Mr. ABC from Chicago to New York, he needs to write the destination postal address of New York on the envelope. If such envelope gets to Chicago post office, it is checked against the destination postal address and forwarded to the New York post office. New York's post office knows where to deliver the envelope based on destination postal address, which is local to New York Post. Considering the post office example, the functionality of a router is similar to the post office. To understand how the router works, we need to understand the process of routing. Routing refers to the process of taking a packet from one host and sending it to another host on different network. It is usually done by the devices called routers. A router is a device that joins network together and routes traffic between them. A router will have at least two ports, one physically connected to one network and other physically connected to another network. A router can connect any number of networks together providing it has dedicated ports for each network. Every interface on the router is assigned a unique layer 3 address called as IP address. The aim of IP address is very similar to postal address. It locates the sender and the receiver within the network. Those IP addresses are saved on the router in a routing table, which lists all possible paths in your network. When a router receives IP packets that needs to be forwarded somewhere else in the network, the router looks at the packet destination IP address and then searches for the routing information in the routing table. Let's take a closer look into the router routing and packet forwarding process. Device A sends the IP packet to device B, which has address of 192.168.4.20. Such packet includes the destination IP address in packet header of device B. Routers have port or more precisely interfaces that are interfacing with other network devices. Interfaces connect the links that are used in packet forwarding. When a packet is coming on R1 on interface FA0/1, that is the ingress interface. Router analyzes the destination IP of the packet, which is 192.168.4.20, then performs the lookup in its routing table, which has entries related to each known destination. Each routing entry stores destination address and address of the next device on the path called next hop device. Now, having the next hop address, router can determine the outgoing interface and sends the packet to router 2, which is accessible through interface FA0/0, that is the egress interface. The same process happens on every router along the path to the destination. Routers don't just route traffic to the other networks, they learn which are the fastest route and use them first. Next, we'll discuss the types of router, starting with wired router. A wired router usually connects directly to the modem or WAN via network cable. They typically come with a port that connects to modem to communicate with the internet and distributes the data packet to the connected computer using other ports to the cable. Cisco 1941 is one of the example of wired router. The next type of router is a wireless router. Wireless router connects directly to a modem through a cable for receiving internet data packets and distributes data packet to the connected computer using one or more antenna. Wireless router create a wireless signal in your home or office. So any PC within the range of wireless routers can connect it and use your internet. Example of wireless routers are Cisco 880 ISR and EA7500. The next router is the edge router. which is a router specialized router residing at the edge or boundary of a network. This router ensures the connectivity of its network with external network, a WAN, or the internet. This type of router is placed at the edge of the ISP network. Edge routers inject classified traffic from the customer into the core and forward from the core to the customer. Cisco ASR 9000 series routers are one of the examples of Cisco Edge routers. Next router is the core router. This router is designed to operate in the internet backbone or core. Core router provides transit packet forwarding service between other core and edge routers. Core routers forward stuff between the edges as fast as possible. They tend to be optimized for high bandwidth. Those routers are used as service providers, core routers. Cisco's TRS carrier routing system is the example of core routers. Next up is vRouter or virtual router. It is a software router that an enterprise or a cloud provider can deploy as a virtual machine in a provider hosted cloud or in its own virtual environment. It delivers comprehensive WAN gateway and network services function into virtual and cloud environment. Uses indus- it uses industry-leading Cisco IS XE software. Two examples of vRouter are CSR 1000V, which is supported across multiple hypervisors, such as VMware vSphere, Microsoft Hyper-V, Amazon AWS, and Microsoft Azure. ISR-V. This router runs on a server platform running the Cisco NFVI virtualization software only. Last, we'll discuss about the advantages of using the routers in the network. Routers are used to segment large networks into internetworks made up of smaller networks that are easier to manage. Routers can connect different network architectures such as Ethernet and token ring. Routers can choose the best path across the network using dynamic routing techniques. Routers reduce network traffic by creating broadcast domain. All ports on a router are in different broadcast domains, and routers don't forward broadcast from one broadcast domain to another. That's it for today. Thank you for watching. Please like and subscribe.